Welcome back to CAD/CAM tutorial. Today we are going to design a simple pulley support assembly in SolidWorks. Here all the parts and we will decide and we will assemble at the end. So this is a good example for the beginners. I hope you like it. So let's see how to make each and every part and assemble a simple pulley support in SolidWorks. Let's start to make the first part of pulley support base. So this is the 115 by 40 millimeter base and the thickness is 5 millimeter. There are 4 number of holes, 5 millimeter each, and the distance is 65 millimeter by 20 millimeter and outer and the located distance 25 by 10. So let's try to make the first part. Top plane sketch. I'll choose here center rectangle and let's make 40 tab 115 enter. We will make one more rectangle and that is 20 tab 65 enter. But for this one click here for construction purpose, say yes. Now look, hole. Let's make hole here and this hole diameter 5, enter. Let's create 3 more holes, exit. Now hold shift key and select all 4 holes and make relation equal. See, our drawing is fully defined. Right click tab and go to sheet metal. We will use sheet metal tool, base flange. See here, now sheet metal thickness 5 millimeter. Look how it's going downward. K factor 0.5. This is keep bending allows standard. Auto relief we don't need here. Say yes. If I am going to save like this, that's it. Now let's save this one part. Go to desktop, create new folder and write here pulley support. Part 1 base. Save. Let's go to next part. New. Okay. Now here the next part is bracket. This is, if you check the vertical length 40, horizontal length also it's 40. You will see here 5 millimeter thick, corner radius R2 and there is 2 holes and one side 15 millimeter from this side and one 10 millimeter hole from this side. So we will flatten and we will see. Let's click base flange. I'll choose here front plane, line. I'll start from here. Select both the lines. Equal. Smart dimension. If you define one dimension, no need to define second more. Now simply exit. Once you click exit, see direction 1, 40 millimeter. Let's make a reverse so it looks perfect. Now thickness is upside, that is what we need. Thickness 5 millimeter, corner radius. You will see here, even though you can change, but this inside radius is 2 millimeter. K factor, everything same as it is. We are not going to discuss anymore for this. Now let's use unfold. I'll select one fixed surface, calculate all bend, say yes. It's flatten. Sketch. I'm going to draw a reference line. Choose the line for construction purpose. Circle. Let's draw here two circles and one circle here. Let's make 10 millimeter. Now let's define those. 15 millimeter, this is also from here to here 15 millimeter, and the distance between these two circles 20 and 10, 5, and this at center means 20. Okay, this one defined. Let me hold shift key and select both the circles, equal relation. Now see, our drawing is fully defined. If you go to sheet metal, you have one option called extruded cut. Here you have one option, click link to thickness, so that it will cut only up to thickness. Otherwise you have all options like through all. Even if you choose bend, you will be able to put here dimension whatever according to thickness, but this is link to thickness is better option for sheet metal. Say now this is folded, click fold. Now this is the fixed surface selected, calculate all bend. Okay, it's fold. Okay, so let's save this one, part 2 bracket. Let's go to new part, and this is pulley. Now let's make this third part as pulley. Now just remember the dimension, outer diameter 40, then inner 33, 66.25 inside, and there is outer one 10 millimeter. See, the outer width 15 millimeter, pulley width. Okay, then this is center is hole. There is a hole at 6.25 millimeter, and there is one more hole, and that is 5 millimeter thick both side. So this one we will use, and 90-degree one chamfer corner cutting is there. For just note down the dimension 4x4 and 90-degree. Front plane, let's draw 4 circle, 40, okay, 33, 10, 6.25. I'll select extruded boss base. I'll choose this one. Thickness, let's keep 15 millimeter. Make it reverse so it makes more sense. Okay. See. Now again click same sketch, extruded cut, and in selected contour choose this one, 5 millimeter depth. Okay, look. Again click same sketch, extruded cut. In selected contour choose the center one and keep end condition through all, say yes. Look, it's throughout hole created, but we need to cut this side also. Either we have option to mirror it, or even though we will use the same option, let's say extruded cut, choose this option. Here you have option surface plane, I'll choose this one, but this is going outside, reverse. Look, 5 millimeter is depth, say yes. Look, we cut without mirroring the things. Okay, let's check another one. Right plane is sketch, center line. Let me draw a center line. Okay, one more line we need a line at, this is axis of revolution. Let's say connect from here to here. Let's make angle 90-degree, that's fine. Distance from outer side 4 millimeter, 4 millimeter, but these are the not defined thing. So what we will do, we will connect Make sure this line, not construction line, horizontal, made this point and this line coincide. Look, drawing is fully defined. It's time to go to feature, choose your revolve cut. Now axis of revolution, keep angle 360 degree. I'll choose axis of revolution, this one. Now you will see the close view. How is going to cut 360 degrees? Say yes. Look. So our pulley is ready. I'll say yellow. Part number 3, pulley. Let's go for next part. New part. Background I'll always change. Now here the next part is washer, 12 by 6.25 and thickness 1 millimeter. Anything, it's not a big deal. Sketch 12, 6.25, extrude 1 millimeter thickness, keep and condition blind 1 millimeter thick, and color we will keep this one. Save. Part number 4, washer 1. New part. Now let's make the part number 5 is socket head screw. The diameter 10 millimeter, thickness 4. Okay. Then this rod 27 millimeter, thickness 6.25. Then here one more threaded portion, 6 millimeter, diameter 4, but this is cosmetic thread. We are not going to apply a real thread. Corner fillet 1, and there is one key bolt hole, 2.5 depth, 4 millimeter. Top plane 10. Extrude feature, and this feature we will extrude up to 4 millimeter. Make reverse. Yes. Select back surface, sketch. Here draw one more circle, and that is 6.25 millimeter. If we choose extrude, 27 millimeter. Look how it's going. Okay. Now let's say sketch. Now here 4 millimeter. And this one we will extrude up to 6 millimeter. Keep and condition blind 6 millimeter. Say yes. Top sketch. Now here we will create one oblong. I'll make horizontal. Now let's make this distance 4 millimeter and choose extruded cut, and depth here we will define 2.5 according to drawing. Say yes. Look, fillet 1 millimeter, constant size fillet, radius 1 millimeter. I'll choose upper edge. Say yes. Look, go to insert, annotation, cosmetic thread. Here I'll choose this edge. Matrix, we will use machine thread. This is the 4 into 0.7 pitch thread going to apply. Here choose up to next. Up to next means up to this whole thickness. This is class standard. Say yes. But you are not able to see any cosmetic thread here. So go to option, documents property, detailing. Click here shaded cosmetic thread. Make sure it is checked. Say yes. Now look. Let me define some color to this body. I'll come. Oh, that's perfect. Say yes. So this is the R socket head. Save. Socket head screw. new. Now let's see what next. Okay, what next is a small washer. This is 10 by 6.25 and 5 millimeter thick. Anything, let's say top plane is sketch 10 millimeter, 6.25 extrude, keep and condition 5 millimeter blind, material appearance orange color, that seems better, save, 6 washer 2. Okay, let's open new part. Now what next? Okay, let's make our customized nut bolt. This is our nut bolt, 10 millimeter, thickness 4, and the rod length 9 millimeter, 5 diameter. But there is one circular cutout. This upper diameter tangent to this corner edge, and 1 millimeter is cutting length, and angle of cutting is 45. I'll show you here, and this is also a cosmetic thread. Top plane is sketch. Let's draw a polygon, or you can say hexagon. Now this hexagon have outer diameter 10. Extrude, keep and condition, blind 4 millimeter. Bottom is sketch. Now here makes circle at center point, and that is 5 millimeter. Extrude, end condition blind 9 millimeter. Top. Now let's make here one cutout. So let's make relation tangent. Look, extruded cut. Now look very carefully. Flip side to cut 1 millimeter only, angle 45 degree. Look, if I'll say yes, look how it cut. Look at the shape. This is what we like to use. Insert annotation cosmetic thread, and let me choose this edge. Machine thread M5 by 0.8 up to next. Say yes. Go to documents, property, detailing. Make sure shaded cosmetic thread checked. Now look. Edit appearance. Brushed steel. Now this is the part number 7, bolt. Let's make again new part, and this is nut, and you will see the nut also similar to the bolt, 10 millimeter. There is inside 4 millimeter hole, and the outer cutout pattern is same, 1 millimeter, 45 degree, thickness 5 millimeter. Top plane is sketch. First we will choose polygon. Make sure any one line horizontal or vertical. Then let's say circle, and inside diameter 4 millimeter. Okay, that seems too big. 10. That's perfect. Extrude, and end condition keep 5 blind. That's it. Top. Now I am going to cut. Tangent, extruded cut. The same thing, keep and condition blind 1 millimeter, flip side to cut 45 degree angle. Look, Now this time we will mirror. First we will create a plane. First, second. So here we are going to see a mid plane. Mirror. Reference this one and extruded cut feature. Look, it's mirror. Click hide. And let's add some cosmetic thread. Select one end, 5 into up to next, because this is a hole. Okay. If I am going to again mention detailing, shaded cosmetic thread. Okay, so look how our nut looks. Save nut. Let's assemble those all parts. Make assembly from part. Okay. Now first part, click base, click here and automatically base will comes here. Okay, again bracket, click, because these all parts are open. Control key, click, drag and copy one more thing. Move, rotate. This one is perfect size. We need to rotate this one. Okay, let's apply mat. Mat. First we will apply, let's say this hole, concentric. Okay, this hole, concentric relation. Okay, now there is a gap. This whole face and this face, coincident relation. Say yes. Now similar to, we will apply to this part. Concentric, this hole, concentric, back surface and top surface, coincident. Look, this is how we fixed. Insert component. Now let's add a small bush here, and that is washer 2. Look, control key, copy and drag one more here. Mat. I'll fix outer surface and inner surface. Concentric. Okay. Wall and this outer face of washer, coincident. See, it is fixed. The similar way we will apply here, concentric relation. This face and this face, coincident relation. Say yes. Now the small bush washer selected. Now let's bring pulley. Again let's insert washer 1 and again insert one more component, socket head screw. Let's make first pulley. Mat. Select this hole and this hole and relation coincident. Okay. Now here we need to fix this one inside this. So we will apply one rule, advanced mat, width mat. I'll choose one face, second face, 2 face of pulley and 2 face of this. So it is going to fix exactly center of this space. Say yes. Look. Select this one and this hole. Concentric relation. Similarly, washer and let's say this one. Concentric relation. Say this wall and this one. Look how it's fixed on this wall. Yes. This face and this face. Okay, now the bolt is screw fixed here. Now let's bring one more washer, the bigger one here we need. Then we need bolt, again insert, and the last one is nut. First fix nut. Coincident met, select the hole and this bolt, concentric relation, say yes. I'll choose the face of nut and face of this bolt. Okay, now it is fixed here, but we need to fix here washer. This whole washer and this face, concentric relation, say this face here, edge selected, face to face, say yes. Now see, washer also fixed here. So we fixed nut, bolt, washer, pulley, hole, bolt, concentric relation, say yes. Select this face, hold, and this face, coincident relation, okay. Now let's apply copy with mats and copy this bolt in all holes. I'll choose part, here select next. First option concentric, second coincident. So what is concentric? This is concentric, this is coincident. Click yes. Now comes here, first option concentric, select hole. See here, bolt preview. Second one, we need to choose coincident. So this is the face. Okay. Yes. Similar here, hole, face. Okay. Cancelled. So we assembled our pulley. So this is the simple tutorial. This is a good example for the beginners, those who want to learn how to create parts and assembly in SolidWorks. I hope you like it. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.